Good evening to everybody. It's a pleasure to be here. Thanks to all the early people who are wishing me good evening. I can't wait for your questions. Please let them come. Good evening to everybody. It's a pleasure to be here. I'm not saying anything. All right. So Srinivas has asked, sir, can you give me an idea of division of negative integers? Example -5/2. What would be the remainder? Okay, so this takes us back to the division algorithm that we have for Euclid, and the remainder is up to us, meaning you may want the remainder to be positive or negative. If you choose the remainder to be positive, then we know what we should do, and if you choose the remainder to be negative, then we know what we should do. So there is something more to this, because we will be talking about continued fractions in some coming weeks. And so in the coming weeks, we will need to talk about these kind of remainders, but they are of a slightly different type, which is that you will have a real number and you will take the integral part out and keep the fractional part. And that fractional part is always defined to be a positive quantity. So I think even for the when we divide -5/2, we can say that we want the remainder to be a positive quantity, and then we know that the remainder should be 1 and not equal to -1. But it's up to us to define. We should have a definition and stick to that for through all the course. That is what we should do. Good evening to all the people who have joined and who are yet coming and asking questions. It's a pleasure to be here. Hi Somendra, it's good to see you here. Okay, so Vaishnavi Kumar is asking, in Legendre symbol AB by P equal to A by P, B by P, should we have to assume GCD AB equal to 1? No, that is not needed. So normally what happens is that once you fix an odd prime P, then you look at the UP, which is the set of all residue classes which are co-prime to P. Okay, and those are the ones that we are looking at. Then Legendre symbol actually gives a group homomorphism from this UP to ±1, and so we have it defined for any 2 A and B, and of course for whenever you have A divisible by P, you can extend the definition of Legendre symbol outside UP. You can define it for the whole ZP by defining it to be 0 on 0. So we don't have to assume that the GCD of the numerators, so to say, is equal to 1. Yog Narasimha is asking, sir, I am aiming to become a theoretical physicist in near future. Can you please tell me the significance of this course in it? I cannot, meaning if it's a binary question, whether I can tell the significance or not, then the answer is I cannot, because I am not really a physicist, and a physicist would know what is applicable in physics. What I can tell you is that, maybe you should look at some of these. There is something called unreasonable effectiveness of mathematics. This is a very nice article. I think it's written by a physicist. And the physicist talks about various things that number theory will not just tell you, meaning if you are just going to study theoretical physics, then maybe for your bachelor's or master's, or perhaps even the first 2 years of your PhD or 3 years, perhaps number theory will not help you. But if you are going to do some very advanced stuff, then number theory may come handy. So modular forms and so on have already been very useful. So this course will lead you to some of the advanced courses in number theory, like algebraic number theory, modular forms, elliptic curves, analytic number theory, maybe probabilistic number theory, combinatorial number theory. There are several things that you can do having completed this course, and those have relations with some of the very advanced physics, even with string theory and so on. So we never know, maybe you can discover something. Please go ahead, Soumendra. If you have a question, please ask. Jaimin Patel is asking, can we use Fermat's little theorem for primality test of given positive integers, since you told about those naughty numbers? Yeah, so to say that something is not a prime, we can always use this Fermat's little theorem. But in general, I think using Fermat's little theorem is a bit slightly difficult. So what happens is that when you are looking for a Fermat's little theorem says that a to the p minus 1 is congruent to 1 mod p, right? And let me just, I'm confused. So let me just see this. Okay, yeah, thanks. So Fermat's little theorem is indeed a power p minus 1 is 1 mod p, and you would want to know whether any given n is prime or not. So you would want to check a power n minus 1, whether it is congruent to 1 mod n. If it is not congruent to 1 mod n, then you would know that n is not a prime. But sometime it may happen that a power n minus 1 may be congruent to 1 mod n for some a. So what I meant about these naughty numbers is that for some random a, of course, you are not going to check for every a, because if you can check for every a whether some certain power is equal to 1 mod n or not, you might as well be able to find factors of n. So you are not going to check for every a. What you are going to do is that you will randomly select some element in z mod nz, and you will then check whether a power n minus 1 is 1 mod n. So quite likely you will get that it's not 1 mod n if n is not a prime, but there are some numbers for which there exist integers a with the property that a power n minus 1 is 1 mod n. And what you need to do is that the primality tests are about, some probability. The primality tests tell you whether some number is a prime or not with some probability. So this will give you some probability, but what you would want to know is that there should be more probability. Abhijit Bhattacharji has asked a question about something. Abhijit, you have sent me your paper. I have not really read it carefully. I told you last time also that, I am not likely to read it very carefully. If I read it, browse through it, and I have some comments, then I give those comments. But other than that, I don't think about it too much. So please, if you have any of your own work, we will not discuss it here. Apurva Rai is asking, is the exam pattern same as that of assignments? If so, is there partial marking for exam? So I don't know what you mean for partial marking, Apurva. Perhaps you are asking whether among the many multiple options that may be correct, and if the students choose only a few of them, then whether there are going to be marks. That in that case, the answer is no. So what should happen is that you should check for all given options, and you should be able to see whether all the given options are correct or not. The exam pattern may be same or may not be same. So what may happen is that I am told that in the final examination we may have questions where you may fill in the blanks. So I may ask you to compute something and write the answer, final answer, in the blanks. That may also be one of the question papers, one of the patterns. So I have not thought about it completely yet. Preeti Kumari is asking how to find the root of quadratic equation in ZP. I think this is already discussed. What you need to find is that you should know what are all the squares. Once you know all the squares, then provided that your P is odd and the leading coefficient, which is the coefficient of x square, is co-prime to P, then you simply use your final formula for solving the quadratics, which is minus b plus minus under root b square minus 4ac divided by 2a, and that will work. Abhijit Bhattacharya is suggesting that a equal to 561 is a pseudo prime. Yeah, that may be so. Thank you. Saumendra De, sir, please, if you discuss un has 8 square roots of 1. Okay, so you know the square roots of 1, what you should try to do is to write un as product of cyclic groups. Once you write it as product of cyclic groups, each cyclic group is going to have 1 or 2 square roots of 1. There will not be more square roots of 1 in a cyclic group, because each cyclic group can have only one subgroup of order 2. It will not have more than one subgroups of order 2. Then the group will not remain cyclic. It's a simple exercise in group theory that you should be able to do. So in a cyclic group, you have either 2 square roots of 1 or 1 square root of 1, which is the identity element. And by looking at the cardinalities of the cyclic factors, you should be able to see whether if there is a z by 2z coming in the thing, or z by 4z coming, or z by 8z coming, or z by 20z coming. All the even numbers will have a subgroup of order 2, and so you will get 2 square roots of 1, whereas all the odd order subgroups will have no square root of 1 other than the identity element. And so you will have no other thing coming from there. So you will have to multiply 2 to 2 each time you have a cyclic factor of even order, and that will give you the final number. That is what one needs to do. Otherwise, I think it is discussed in the lecture, and I here cannot do anything more that has been discussed in the lecture as far as this thing is concerned. Given in the assignment. So assignment 7 solutions will be uploaded soon. So I will give it to the NPTEL staff. All these solutions will be given to them with slight more details, and they will upload the solutions. So Soumendra, I think this is particularly the thing that was discussed already. I have given some brief answers to some of the questions, and you have to look at prime factors of these numbers. So for instance, if you take the first number, I will not of course discuss all of these, but suppose you take the first number, which is 140, then 140 is 4 into 35, right? So the z modulo 140 is going to be isomorphic to z by 4 cross z by 5 cross z by 7, right? The group of numbers modulo 140 is a product of 3 cyclic groups, z by 4z, z by 5z, and z by 7z. And we have to look at units in these. So z by 7z will give you units which are u7, and u7 are 6 elements. Similarly, z by 5z will give you units which are u5, that has 4 elements. And z by 4z, the units are only 2, 1 and 3. Okay, so though that is 2 elements. So you have z by 2z cross z by 4z cross z by 6z. And you have 3 cyclic subgroups of even order, giving you the full group U140. and therefore each of them will give you 2 square roots of 1, and so in all you have 2 into 2 into 2. So that gives you 8 square roots of 1. A similar discussion will tell you what should happen in the remaining cases. Yogan Narasimha is asking, sir, in the exam, will we be required to prove something or some theorem? So at the moment, I am not going to ask for any such thing. I am not going to ask for any descriptive questions simply because we don't have manpowers to grade all the answers that will come. So everything will be auto-gradable. You are welcome, Soumendra. I think in the last session, several people had complained that there is only one session and they wanted to have more than. They said that only one session per month is not enough. They wanted more sessions. So now let's have the questions come. I hope you are all enjoying the course. It's a bit difficult course now because we are getting into some of the advanced things, but it's of course a very interesting thing to do. Meaning some of these results are so beautiful that it would be difficult to get proof of those results. Okay, so Apurva Rai is asking another question: which of the polynomials fx have a root modulo every prime p? So x square minus 3 into x square minus 6 into x square minus 9. Now, whether your whatever p you take, the class of 3 modulo p will always give you a solution, because the last part x square minus 9 is going to have a 0 every time. X square minus a square will always have a 0 given by x equal to a. So x square minus 9 is always something which will have a root modulo every prime. Even if the prime is 3, you have a root. I did not ask for root somewhere else. I did not ask for root in UP. I said that there should be a root in modulo the prime p. And x square minus 9 will always have a root. So we should have that. What is the intuition behind quadratic reciprocity law 3? That is a question that Madhuri is asking. This is a difficult question. It's difficult to think about what Gauss may have thought when he thought about this question, but it is something very natural to ask about what would happen. This is not restricted to only this study. Meaning whenever you look at this, reciprocity in general is not restricted to only quadratic. There is a cubic reciprocity law, there is a quartic reciprocity law, and in general there is what is called Artin reciprocity law. So this is something that these kind of things, whether such a result should be true or not, will come only when one has very deep thinking about various mathematical things. And of course Gauss would have done many experiments and would have found that whenever you do some computations, the Legendre symbol for p by q and the Legendre symbol for q by p are nicely related, and that is how he may have thought about this. Of course, Gauss had many such wonderful results. Gauss is the one who conjectured the prime number theorem. So looking at some small examples, Gauss was a master in getting and guessing the final answer. So that's all that I can say about the intuition behind quadratic reciprocity law. But the only nice thing that I can tell here is that there are higher reciprocity laws. Abhijit Bhattacharya is asking, how is this course related to cryptography? You know, typically in cryptography, you would want to learn congruences and several things. And if you're going to elliptic curve cryptography and so on, then you will need to know even more stuff. So this kind of course will tell you some of the basic things which are used in cryptography. This is how this course can be said to be related to cryptography. Karuna Sharma is asking, good evening, sir. What are the applications of Legendre symbol? Legendre symbol will tell you whether a number is a square or not, modulo p. And whenever such a thing comes, for instance, if you want to solve a quadratic equation, somebody was asking just slightly before you, then you would want to know what are all the numbers which are squares modulo p, and that's where Legendre symbol will come and help you. So Legendre symbol is really a tool to tell you that something can be a square or not is something which is related to products, meaning whether AB is a square or not is related to A and B both being squares or non-squares. That is where we use the Legendre symbol. I would see that Legendre symbol is only a language to transform some kind of computation into some another kind of computation, and therefore it is useful in helping us finding roots of the quadratic equations. Srihari Kulkarni is asking, square root of minus I can't be solved or magic complex number? What do you mean it can't be solved? Square root of minus I can of course be solved. Within complex numbers, there are two square roots of every non-zero complex number. So 0 is the only complex number which has only one square root, which is 0. But other than that, every complex number has exactly two complex roots. So square root of minus I does of course exist. There are many ways to look at it. For instance, you would say that I is something which is, on when you go from one positive direction of x-axis, you go in the anti-clockwise direction by 90 degrees and you find I. So in the anti-clockwise direction, you go 270 degrees or clockwise direction 90 degrees and you get your minus I. And now modulus is 1. You may either look at the angle being negative 90 or 270, divide the angle by 2. So you get negative 45, which is, you may look at 1 minus I, take the sum and make the modulus 1. Okay, so it is 1 plus minus I. So that is 1 minus I upon norm 1 minus I. That is the complex number whose square will be minus I, and its negative will also give you the square to be minus I. So I don't understand what is your comment about magic complex number, but square root of minus I definitely has a solution. Saumendra is asking, sir, how can I determine fx have a have a root modulo every prime p, x square minus 2, x square minus 3, x square minus 6. I cannot solve this problem and also discuss the methods. Okay, Saumendra, so in this problem in particular, what we had was that you need to check whether for a given prime 2 is a solution. So, meaning assume that your p is bigger than 3. In that case, whenever there is a root to any of these polynomials, we have written our polynomial of 6 degrees as a product of 3 degree 2 polynomials. So whenever there is a root for the whole polynomial, one of these should have a root. And so we are looking at either 2 being a square, or so given a prime p, forget about the small primes 2 and 3. If for 2, 2 is always a square, for 3, 3 is always a square. Okay, so there we have that the polynomials have root. Now if you look at anything higher than 3, you take a prime p which is bigger than 3. Either 2 will have a square root, in which case you do get a root for the polynomial, or 3 will have a square root, in which case you get a root again, because x square minus 3 has a root. And if 2 and 3 are both non-quadratic residues, then their product has to be a quadratic residue. And so 6 will have to be a square. So this polynomial x square minus 2 into x square minus 3 into x square minus 6 will always have solutions. In general, whenever we are given any number a, and we are looking for all primes where a is square modulo the prime p, Then we have discussed this in one of the problems in our lecture, that you can use quadratic reciprocity laws and get some congruence classes, where you will have that A is square modulo P if and only if P satisfies some list of congruence classes modulo the given numbers. So that's how one would solve this thing. Vaishnavi Kumar is asking, if n is not prime, how to prove Zn has an idempotent element different from 0 and 1? So where is this question coming from, Vaishnavi? Tell me where this question is coming from. This is not something from our course. So tell me where it is coming from and I may give an answer. Dharmendra Singh Azad Hindustani wants to know, how can we do research in analytic number theory ourselves, as we are unable to go under a regular guide? So any subject, forget about analytic number theory. If you want to work in any subject, the basic thing you should be able to do is to read about it. So nowadays with internet, there are so many resources which are available to us. So you should be able to find good notes on analytic number theory. You should be able to see and some good lectures on YouTube. You will find lectures of various nice people coming from many institutes and universities, both in India and abroad. And you should be able to prepare yourself having learned some basic stuff. Once you learn some such basic thing, then you should read some of the recent research articles. So if you want to really do analytic number theory, you should search for research or articles on analytic number theory on Google. What happens is that for any such area, there are conferences which are held regularly. So regularly people meet. Forget about these 8-9 months. These have been non-regular. So people would, in regular time, people would meet and they would discuss and they will tell each other about their work and they will write these things and these are published ultimately. So these are called conference proceedings. So various conferences are held throughout the world. Their conference proceedings are published. You may just search for conferences on analytic number theory and you will get to see that there are several nice things which people discuss. You read those research articles and then you try to see whether you can improve in any one of them. If you are able to improve in any one of them, you should write it up nicely and send it to those people who are working in the area and then take it from there. That's how one could work in any area, meaning not just analytic number theory. Vaishnavi, I am still waiting for answer coming from you. If n is not prime, how to prove Zn has idempotent elements different from 0 and 1? You should tell me where this question is coming from and I will give you an answer. A hint for you to think about this answer is the Chinese remainder theorem. Govindraj is asking, sir, can we say 0 equals infinity? No, we cannot. 0 is not equal to infinity. So I would make a comment here, you know, that whatever assignment problems you have been given, they are not extremely difficult problems. You have to think about it. What I would really suggest is that, you know, whenever the lectures are released, the assignment questions are also released at the same time. So you should keep the assignment questions in mind, and while learning the lectures, while going through the lectures, you will perhaps see various things which can be applied readily to the assignment problems. Govindraj has again written 1 minus 1 equal to 0, right? Yes, that is true. 1 minus 1 is 0 and 0 minus 0 is infinity. How do you get this? 0 minus 0 is not infinity. 0 minus 0 is 0. Vaishnavi Kuwar said, sir, it has the proof related to CRT. Yeah, Chinese remainder theorem. So what happens is that, you know, if you're, okay, so maybe I'll give the answer. So if your n is not a prime, then n has at least two factors, a and b, and assume that these a and b are co-prime. Okay, so if they are co-prime, then what you will have, okay, so let's think about it. So to have an idempotent, you should have a square minus a square congruent to a modulo n, and which will give you a into a minus 1 is 0 mod n. So n should divide a into a minus 1. So n will have a factor. Okay, so for instance, you may take the factor to be, you may take a factor which is bigger than n by 2. All right, and okay, so there are two cases that one can make here. So the two cases would be that you have two factors which are co-prime, because if you have prime decomposition, you take all prime factor in one particular set of primes, and the remaining set of primes will give you the other factorization. So you have written your n as product of two numbers which are co-prime to each other. Okay, Z mod NZ will then be isomorphic to Z mod A cross Z mod B. And in Z mod AZ, you already have two idempotents, namely 0 and 1. In Z mod B, you have two idempotents, 0 and 1. So combining, then you get four idempotents. So whenever you have been able to write n as product of two relatively prime numbers, you have more than two idempotents this way. Now you have to work with the case where n is a power of a prime. So n is, say, power of a single prime, and it can be p square, p cube, or any such higher power. And then you have to simply observe that if it is p power r, if n is p power r, then p power r minus 1, its square is going to give you, okay, so its square will give you 0. That's not what you want. You want to get an idempotent. But then this is not true, right? Meaning n equal to 4. 4 is not a prime, and we don't have non-trivial idempotents in n equal to 4. I think in Z mod nz square, I'm not sure if you are going to get non-trivial idempotents every time. So maybe you should think about your question again, Vaishnavi. Okay, there have been a few comments. Srihari Kulkarni is again making a comment, sir. Mathematical concepts in quantum computers, like 0 is false and 1 is true in normal computers. So what is in quantum computers? I have no idea, Srihari. Meaning today I am being asked questions which are outside my domain of expertise. It started with theoretical physics. We should hunt the person who asked me the question on theoretical physics and blame everything upon him. What I believe is that, in quantum computers, one need not always be true. You may have something true between 0 and 1. I think that is what happens in quantum computers. Wilson's Abhijit Bhattacharya is asking, Wilson's theorem give us necessary and sufficient condition for a natural number to be a prime, but it has no practical use. Can you say something about the necessary and sufficient condition to be a prime? Necessary and sufficient condition to be a prime is that it should have no non-trivial factor. Other than that, there is no other condition. Meaning, otherwise, we have no, already getting primality tests has been a big deal. And what I should really say is that there is no equivalent condition known until now. There are several primality tests which are available, and a few years back, our Indian researchers proved that primes is in P. So you have a polynomial time algorithm to determine something is a prime or not. But my understanding is that none of these tests give you the full answer. They will give you the answer only up to some probability. What happens is that once the probability is very high, then you may actually say that the number is prime. This is my understanding. So please take it with a pinch of salt. Madhuri Agrawal is asking, sir, can you please explain more about how to find lattice point on a line when line is not passing through origin? You have a line, presumably in R2, and you want to know whether it has a lattice point and your line is not passing through origin. Well, if you know what the slopes and so on, then maybe one would just be able to solve that. Other than that, meaning, is it coming from some another problem? Maybe then I may be able to throw better light on this. But other than that, one would just have to solve the equation of the line. Your line will be given by some ax plus by plus c equal to 0. And presumably, if you are asking for a lattice point, that means you want to know whether x and y have solutions in integers. Then, and if you're depending on your a and b, if your a and b are also integers, c will have to be an integer. That's a necessary condition. And I think if you have a, b, c to be all integers, then one can easily find out whether or not it has lattice points. If you are given some weird equation, even if you have equation over rational numbers, you can clear the denominators and get an equation with only integer solutions. And integer solutions, okay, so you want to know whether, okay, I think this is something that can be done easily. So your equation is, say, something like ax plus by plus c equal to 0. This is how the equation is given, and I am assuming here that a, b, c are all integers. So I would say that you need to look at the GCD. So whenever you have any integer solution, you will be able to write minus c as a linear combination of a and b. And we know when we know all natural numbers, or we know all integers, which can be written as the linear combination of a and b over integers, the GCD of a and b should divide c. So in particular, if a and b are co-prime, then for every c you will have some lattice point. So, meaning you were saying that the line is not passing through origin, and therefore your c is a non-zero element, but we are assuming that it is integer, and then we have this following thing. Otherwise, if your a, b, c are not necessarily integers, then you will have to find the group generated by a and b and see whether c belongs to that or not. But that will be a more difficult thing to do. Okay, so Govindraj has, I think Govind is the same person who asked about 0 and infinity. So he is again suggesting something. According to some paradox, it is said that from 0 to 1, there is an infinite number. So Govindraj, please don't use short forms. When you use RT, I don't understand what you mean by this. Maybe you want to say that there are infinitely many numbers from 0 to 1, right? That's what you perhaps mean. So assuming that 0 itself can be seen as an undefined number, or if it cannot be treated as number, since 0 represent no less. Okay, so 0 represent numberlessness. This is not true, meaning it depends on how you start with this. All these paradoxes and so on have a beginning point. When you are saying that from 0 to 1 there are infinitely many numbers, that means you have fixed a point to be 0. How do you start doing all these mathematical things? You will take the line, which we call the real line. You take any line, put it horizontal, and fix a point on that. So that's the point 0. Then once you have fixed a point, there is a positive direction and a negative direction. In the positive direction, you mark one more point. Okay, so that you are doing this marking in the positive direction. That means you are taking a number different from 0. Okay, so that is the number which is 1. And once you have 1, you have 2, because it will have the exact same distance. Now with the ruler and compass, you will be able to plot 2, 3. Then on the negative side, you will have -1, -2, -3, and so on. So you have a whole set of integers. Then you will be able to have rational numbers, because using ruler and compass, you will be able to divide n into m parts. So you will be able to mark the number n by m also on the negative side. So you have all rationals, and then you use Cauchy's theory or maybe the Dedekind cuts or so, and you have the real numbers. That's how one starts discussing even about something being countably infinite or uncountably infinite and all those things. You start by putting 0. Once you start with 0 and 1, and then you say that there are infinitely many numbers, and then you think that, oh, my 0 is not defined, then it's not a correct thing. You have started the whole discussion by fixing a 0. If you are not putting a 0 and if you're not putting a 1, then your statement that there are infinitely many numbers between 0 and 1 has no meaning. So when you're talking about something being infinite between two numbers, then that means that you are starting with some well-defined notions of those two numbers. Okay, and therefore the further discussion, it might be some logical amusement that one may get out of it, but it has no basis. So Madhuri Agrawal is again asking, we use lattice point for the proof of quadratic reciprocity law. Correct. So, there I think again the same GCD argument will tell you that those lines that we had drawn have no lattice point. That's what one would have, because the corresponding things, I think there you would have p x minus qi equal to 1 by 2 or some such thing. And because p and q are primes, there is no integer solution which will give you 1 by 2 or negative 1 by 2. I think there is some such argument that one has to give there. Narasimhan is asking, in our assignment problems, we have multiple correct answers. If we forget to mark one correct answer, we lose the whole marks. This is correct, because what happens is that many times people are happy with partial marks, and once they find one correct answer, they simply ignore all the answers. And meaning my policy is that one should be able to look at all solutions, verify all whether they are solutions or not, and then mark the correct answers. And finally, you have to be careful in everything you do. If you're not careful, then you are losing something or other. And while one may make an argument saying that, we are okay with losing partial marks, but losing whole thing is not correct. But it's a perspective that one will have to go with. And this is the rule that we have anyway, meaning this is the rule that we have been following since the beginning of the course. We cannot change it midway through. If you have any compelling argument, then please write it on our discussion forum, and I will think about it whenever I give the next course. Govindraj is again asking, so can we say 0 is a multidimensional entity, as 0 can have existence in different real line? 0 is a multidimensional entity. 0 is why only 0? Everything is a multidimensional entity. Meaning, until you know about the plane, you may be thinking, when we learn about real line in our school, we think that everything is only on the line. But of course, in life, we have been seeing things in 3 dimensions. So we do see things happening everywhere as, something which is given by 3 coordinates. And once you know that there is another coordinate called time, then you have 4 coordinates. And now string theory will come and tell you that there are actually 8 coordinates that describes the whole life. So there are 8 coordinates. So everything is a multi-dimensional thing. Why not? And he is again using, then again, if we take infinite real line of some parameters, then there will be a different 0. I didn't understand. So as I am a novice. So yeah, if you take a different real line, then there will be a different 0, but it has nothing to do with the first 0 that you have started with. So if you take 2 parallel lines and you are going to do arithmetic on both of these, what is a 0 after all? I told you that you have to begin by marking 0. So once you mark the 0, then you mark 1, and then you mark 2 and other things. You can do the whole arithmetic. But I may mark a 0 somewhere else, at some place, and somebody else may mark it somewhere else. Then both the things will be different, meaning it depends on your definition. If you are doing arithmetic on a line, you fix a line, work with that line, work with the 0 that you have fixed, work with the 1, 2, 3 that you have fixed, and then you do your mathematics. If you are going to think about different things, then of course you will have different things. This is, I think, this has many analogies that one can have. Suppose you have only one room in your house, and then there is only one bathroom. And whenever you want to take bath, then there is no choice that you have. There is a canonical choice. You have to go to the bathroom and take a bath. If you have multiple bathrooms, you of course have to make a choice of the bathroom where you are going to take bath. You may decide it to do it in any way, but there is a choice that you have to make. So for everything, there is a choice that we have to make, right? So you may take multiple lines, but if you are going to do arithmetic, you should fix one line and work with that line. Ramanujan, Srihari Kulkarni is asking, are we taking Ramanujan theorem on infinity in this course? What is the theorem? Can you please tell me? Let me search for Ramanujan theorem of infinity. Okay. Aha. Do you mean the thing that 1 plus 2 plus 3 plus dot 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 is equal to, well, Ramanujan may have actually Ramanujan said it to be minus 1 by 12, but the first site that I am getting says minus 1. So which is your Ramanujan theorem? Can you please state the theorem? Okay, so it is minus 1 by 12, correct. Okay, so there is a very interesting equation that Ramanujan wrote, and the equation was 1 plus 2 plus 3 plus dot 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 equal to minus 1 upon 12. This is what Ramanujan wrote. And one can give some proofs of this, because you may think basically what we normally do in mathematics is that we don't divide by 0. But if you are going to divide and multiply by 0, which is the same thing as dividing and multiplying by infinity, which is the same thing as dividing and multiplying by divergent series, then there is apparently a proof to get that 1 plus 2 plus 3 plus dot 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 is minus 1 by 12. But there is a nice way to look at the whole thing. So let me give some more details on this. We consider, in your basic analysis course, you may have considered the following kinds of sums. And the first sum that comes, that I'm going to talk about is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and dot dot dot. So in the first course in analysis, one proves that this is a divergent series, meaning this sum can be made bigger than any real number. In fact, it can be made bigger than any natural number. This is quite nice to see, because so one would give lots of proofs for this. One proof may go as follows, that you have 1 and the next number is 1 by 2. And the next two numbers are 1 by 3 plus 1 by 4. So both are bigger than or equal to 1 by 4, 1 by 4, right? So 1 by 3 plus 1 by 4 is bigger than 1 by 2. Okay, so you have got 1 plus 1 by 2 plus two terms whose sum is bigger than 1 by 2. We have gone up to the fourth term of the sequence. Then you have four next terms, 1 by 5, 1 by 6, 1 by 7, 1 by 8. So these are four terms, each of them being bigger than or equal to 1 by 8. So this sum is again bigger than 1 by 2, strictly bigger than 1 by 2. So then we are done with 8 numbers. Next we look at the 8 numbers, which will be from 1 by 9 to 1 by 16. These are 8 numbers, all bigger than or equal to 1 by 16. So the sum is bigger than 1 by 2. So you get infinitely many such sums giving you something which is bigger than 1 by 2. And therefore the whole series diverges. So 1 plus 1 by 2 plus 1 by 3 plus dot dot dot, this is a divergent series. This is what we learn in our first course in analysis. But if you take 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus 1 by 5 square and dot dot dot, then this is a convergent series. In fact, please go and check what it converges to. It has a very interesting answer. Okay, so this, when you replace the powers instead of 1, you put them as 2, then you get a convergent series. Similarly, if you look at 1 plus 1 by 1 cube plus 1 by 2, okay, so you have 1 already, so we will not take 1 by 1 cube. 1 plus 1 by 2 cube plus 1 by 3 cube plus 1 by 4 cube and dot dot dot, that again converges in real line, and its limit is called zeta 3. It is not equal to anything else that we know so far. The earlier sum 1 plus 1 by 2 square plus 1 by 3 square is related to pi square. Okay, I think it is pi square by 12 if I am not wrong. But for 3, the sum of reciprocals of cubes of natural numbers, that is a real number. The sum gives you a real number which is not related to any of the known real numbers that we have. So we will call it zeta 3. We will give it some name. We call it zeta 3 and so on. So whenever you have the power to be anything bigger than 1, then you have that the series 1 upon n power s to be a convergent series. Okay, pi square by 6 as Mohammed is suggesting. It could be that. Okay, so you're looking at 1 upon n power s, where s is some real number which is bigger than 1. Then the series is convergent. Now, when you are looking at complex numbers and you are trying to put the power as a complex number, then you have to deal with the branch of logarithm, because you are talking about a power a complex number. So that can be discussed by taking some certain logarithm and so on. We will assume that it can be done. But once it can be done, then there is a nice result that you take this half plane, which is that real part of your complex number s is bigger than 1. Okay, so you have this whole complex plane, and in that you are taking the half plane which is or whose real part is bigger than 1. This function can be this function is actually an analytic function in this whole half plane. Okay, and it has a pole at s equal to 1, because we have seen that the series 1 plus 1 by 2 plus 1 by 3 plus dot 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 diverges. Okay, so it has a pole at s equal to 1. And now the question that one may ask is whether you can extend this complex analytic function to the remaining part of the complex plane. If you can extend it, then there is only one way to do it. This is what is called the identity theorem in complex analysis, which says that if two functions agree on a set which has a limit point, then the functions agree on the whole simply connected set containing your set of limit points. So once you extend it, actually the theorem goes ahead and it gives you extension of this function. This is called the Riemann zeta function, and you have extension of this. The function can be extended to the whole complex plane with a pole at s equal to 1. There is no pole at s equal to 0, but there is a pole at s equal to 1. And hold it, the value at -1 is -1 by 12. So if you are putting s equal to -1 in summation 1 upon n power s, you are going to put summation 1 upon n power -1. And so you are going to get summation n. So actually that's not how the function is going to be defined. But on the right side of the line, s equal to the real part equal to 1, the function is defined by 1 upon some n power s and taking the sum over n. And it's a great coincidence, and I don't think it's a coincidence. I think it's a great insight that Ramanujan had, where he wrote that 1 plus 2 plus 3 dot 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 is -1 by 12. I think he had understood this quite well. We should not forget that Ramanujan had read this book of Carr on analysis. Ramanujan was very proficient in analysis, complex analysis, and he had proved many results. So he knew what he was doing. So this is the theorem of Ramanujan on infinity. In case this is the thing that you wanted to know, then this is it, and we are not going to discuss it in our lectures. D. Narasimhan is saying, sir, please provide us the model question paper or question paper pattern or question bank for December examination. all the assignments that you are receiving are models of question paper. There is no other thing that I can provide. Meaning there has to be something. Sometime I feel that we cannot provide each and everything. You should be prepared. Once you have mastered the course, you should be prepared to do. If you want to do very well, if you want to get 90% out of 100%, then you should be prepared to solve every question that comes your way. And if you're not able to solve that, that is still okay, because you will still be able to get a good score, even if you are not able to answer some of these slightly so-called difficult questions. But I think what you should understand is that all the questions that I am asking will ask you to apply the knowledge that you have received. So lecture courses have given some theorems, some corollaries, maybe some examples which may not have been enough. After all, we had to cover a lot. And my experience of having taught for several years is that anything that you provide, there is always some student or otherwise who is not going to be satisfied with that. So I have, of course, no problem with all the learners saying that we are not happy with what you have given, it is not enough, and so on. But this is a fact that nobody is going to satisfy all students at one go. So there has to be a line that we have to draw, and this is where I draw the line. Okay, that we will all the assignment questions that you have, those are the model questions for you. You may have some extra patterns, perhaps something like writing the final answer and so on. I may ask you to write the reduced form of a given binary quadratic form, and there will be blanks for the coefficient of x square, blank for coefficient of xy, and blank for coefficient of y square. And you will have to write the final answer. But beyond that, I also haven't thought much about this question paper. Okay, Sangeeta is asking, sir, how do we find primitive roots modulo n? And how many, maybe she means primitive roots, how many primitive roots we will get? I am confused with that topic, sir. Please, can I get explanation for solutions of the questions provided in assignment 6? All right, so sure. So if the assignment solutions are being uploaded by the NPTEL staff, what I'm going to do is that I'm going to send some more details to the assignment solutions. And so when they upload these solutions, there will be slightly more details. I cannot give, the whole whole working out of a solution in every detail for all the 10 questions for every assignment. That is beyond my capacity as an instructor, and I think it serves no purpose, because if I ask you something which is not in that set, then you will not be able to do it. If you are able to solve the question papers by whatever details I will give, then you should be able to solve any question that comes, whether in the same set or in the outside. Okay, so I will give some details. I will send them to the NPTEL staff and they will upload them. I think so far solutions up to assignment 7 have been uploaded. So I'm going to give them again modified PDF files of those solutions with slightly more details, and those will be uploaded. So wait for the solutions. Don't ask me by writing emails every day. That is not going to serve any purpose, because the solutions now on will come only through NPTEL staff. I hope that answers Sangeeta's question. Madhuri is asking, sir, how to study something from research point of view? All the while in MSc we study mainly for good marks. This is very true. Meaning even when I went for doing PhD, I found that there was some difference between studying for PhD and studying for marks. So, the first thing that we should all learn is that whenever we learn any new result, we should meditate about this result on our own. Okay, so if you are learning any book on your own, any mathematical book or any mathematical topic on your own, I would suggest the following idea, that you read basic definitions. Once you have the definitions, you should be able to get some set of examples and maybe one or two non-examples. Okay. So once you have this ready, then read the statements of the theorem and try to prove them yourself. This is because ultimately when you are doing research, you are going to prove theorems of your own. So you should get into this habit of proving theorems on your own, whether they are well-known theorems or not. Okay, so whenever you read a book, you should meditate upon that. You should think about the statement. You should try to prove the statements on your own. Quite likely, you will have some problem. You will be stuck at some step. If you are really, you decide a time for yourself. You may decide that I'm going to think about this theorem only for 1 hour, and then if I am not able to prove it in 1 hour, I will go back to the book and read it. That is okay. You should fix a time. Okay, so if you are not able to solve it within 1 hour, you will typically be stuck at a step. And when you go back to the book, maybe the book will have a different way of proving it, which will enable you to learn that different way, or it may go through the same method that you were thinking about, and it will also tell you how to go beyond the step where you were stuck. And that will teach you a lot, because you were stuck at some point because perhaps you did not think about something. And when you see the proofs, then you would say that, oh, this is something that I should have thought about. And trust me, if you make a mistake and then you understand that it was a mistake, or if there was something which you missed and somebody tells you about it, then that is something that you are going to remember for a long, long time. I think nobody likes to be told about a mistake. So whenever you make mistake and somebody tells you about it, you are not going to easily forget it. So you will learn all these new techniques of proof whenever you do these things, and ultimately you will be able to start proving the theorems on your own. Meaning, many times we go to research conferences and we see that while the speaker is writing the proof on the board, there are people in the audience who suggest the proof, or maybe even a better proof. That happens many times. That is because people are able to think about these things. I think what is important is that you should be able to think about something, and that is the correct way to go about doing research. Bhavdharani Kumar is asking, sir, will this course be available next semester also? I am not planning to teach it next semester. I may give the same course again. I think, in NPTEL, there is a provision of repeating the course once you have the whole material ready. So, but it is definitely not going to be available next semester. I am not going to teach it. Maybe somebody else will teach it, and then you will have the course. But at the moment, I don't have plans of teaching the course again in the next semester. Govind Raj is again one, sir. Last question for me. Why last? Govind asked questions, meaning I may give detailed answer or I may not give detailed answers, but you should ask questions. So his question is, if we say 0 minus 0, then what does it mean? So 0. So this is something that I think I have said in my class, and Madhuri had applied it very nicely to get answer about what was it? I think it was the similar thing. I had talked about P upon Q being that number which when multiplied by Q gives you P. So the negative or subtraction should be thought of in the same way. We will say that A minus B is that number which when added to B gives you A. So 0 minus 0 is that number, call it alpha. So 0 minus 0 is alpha, such that when you add 0 to alpha, you should get 0. Now, if you add 0 to alpha, the addition will tell you that you should get alpha, right? And then adding 0 to alpha should give you 0. So alpha should itself be 0. So my 0 minus 0 is 0, meaning I don't know what other book of mathematics you are reading, Govind, that you are getting some different answer for 0 minus 0. I think we are well beyond 6 o'clock. I don't know how long this should go on. So the NPTEL staff may take a call on this. Sandeep sir, are you around?
Yes, sir.
Okay, how much time do we have?
If it is over, you can wind up, sir. It's already time is 6.
Okay, so it is already 6 o'clock, and at the moment when I see the things in the chat, I have not seen any questions. So
Sir, if learners has more questions, they can ask on the discussion forum.
that is always true. So if you have any more questions, then you can always ask in the discussion forum. I have said it was nice talking to you all. There will be one more session, the last session, and I hope to see you in that session also. Keep safe and keep well. See you in the next session. Bye.
Thank you, sir.
We can wind up.
Yes, sir. You can leave this meeting. Thank you, sir.
Okay, I will leave the meeting. Thank you very much.